Hey folks, welcome back to another episode of JavaScript Jabber. This week on our panel we have Dan Shapir.
Hey, from sunny Tel Aviv.
AJ O'Neill.
Yo, coming at you live from the clouds.
Steve Edwards.
Yo. Sorry, AJ, didn't mean to step on you there. Hello from a still cool and cloudy Portland, wishing it was sunny like Tel Aviv.
Nice. We also have a new host, that's Tejas Kumar.
Hey, from kind of cold, kind of nice Berlin.
I'm Charles Max Wood from Top End Devs. We have two guests this week. We have Dan Abramov.
Hi there.
We also have Joe Savona. Joe.
Hey, thanks for having us.
Yeah, well, we got you on to talk about React server components. And I know you've been on a few other podcasts kind of talking about the topic, but assuming that there are people that may not know what they are and assuming that they haven't listened to any of those episodes, do you want to kind of give us the 10,000-foot view, what they are and why they matter? And then we can ask you all of our deep and scary questions.
Sure. I can maybe start, and then Dan can provide some more detail. I guess, so server components are React components that run only on the server. So it's a kind of common point of confusion. People think of server-side rendering. Right, server-side rendering is where you take your existing client application and run it, kind of pre-run it on the server. Server components are components that run only on the server. So that means you can do things that a regular client component can't because that code is running on the server. So, for example, you can access your database. You can access backend services that you don't want to expose to the front end, and then you can. So you can write async components because these are components that are running on the server. They're going to run just once, and so you can write async await, and then choose which client component you actually want to render, and then pass that data down to the client. So you can kind of think of it like server components are fetching data and then passing that as props to handing it off to client components for interactivity. And so this kind of opens up more a model where you can really use the server for what it's good for, use the client for where you need interactivity, and kind of a lot of the kind of complicated things that you might have to do today, like using an effect or storing server data in state and kind of managing that lifecycle happens a lot more naturally because it just falls out of the server components model. That's the sort of high level view. So if you're familiar with using PHP with React on the front end, or Rails with React on the front end, this is kind of like that, except with server components taking the place of that traditional server-side framework. But kind of depending on where your background and where you're coming from, you might have different analogies for that. But I'm sure Dan has more to add.
Yeah, I think it's a little bit tricky to explain because the way you explain depends on the audience. I think maybe one way to say it is it kind of lets you build full stack React applications, where by full stack I mean that it's kind of like the React backend as well as the React front end. And the idea is that instead of writing the backend and the front end in like two different ways, or thinking about it from the perspective of exposing an API, you kind of think of the whole thing as a component tree. And so if you have been building web apps in early 2000s, you probably remember this simple mental model of, and if you haven't, I'm just describing, like the way you would write it is, for example, you could create a page called about PHP or index PHP or feed PHP or whatever, just the kind of the entry points, the pages that the user can visit. And then you could, you could call some kind of API, or you could read directly from the database. You could use the database, an abstraction, so some kind of database access layer. But the mental model would be you can just grab some data, map it to some kind of output, and and that is the page that the user is going to see. And so this request response model is very nice to think in because you only think about here's the page that the user wanted, and here's the data that it needs. Here's how to get this data, and then let's just return the page. But the downside of this approach with traditional server-side technologies like PHP and Rails and so on is that the page cannot update. So if the user clicks on another link or the user modifies something in the database, the only way to kind of like in this traditional model, the only thing you can do is really reload the entire page. So, the user clicks the link and then the browser goes, fetches the new HTML page and displays it. And so this lets you stay in this kind of request response model. But from the user perspective, all the, if you had a video playing, it will reset. There's no way to like animate this transition. If you had some kind of shared state, it would get reset in the components because you're always replacing the page. And so I think in the 2010s, the dominant paradigm for a lot of apps has shifted to client side, where you kind of, you describe the UI on the client, and then that allows you to do client-side routing. So when you click a link, we keep the page intact, but we just replace the parts, maybe the part of the route that has changed, but we don't reset the state of the entire page. But then from the developer point of view, this is a much more complex model because you have to kind of think about state, like server data as part of your state management. You have to think about how to cache it. You have to think about how to actually like trigger the fetches, how to do progress indication. And a lot of those things, they become pretty complex. And I think that's when people say they're kind of tired of SPAs, I think a lot of it is about, it's pretty hard to think, in this model of continuously running app, as opposed to the model of, I just go to the page and it returns some UI to me. And so really I think the idea of server components is, what if we could really have both? So what if we could, describe the UI as a React tree, but then parts of that React tree, they execute in the place, on the server where you have the database, you have, easy access to you can call your microservices without ever exposing them. You don't have to like build a publicly consumable API. So those components kind of live on the server, but then you can kind of progressively enhance them with the React you already know. So you can have, client components that have state. You can have like animations, you can have videos, you can have forms, like all these things that you use React today for. And then these things are a single tree. So you kind of write your code from the perspective of, here's the request, here's the response, but then the user experience is more similar to single page apps where you can continuously navigate or continuously do something within the app, and the page does not reload, state does not get destroyed. It just stays there. And one thing that's worth clarifying, because I feel like a lot of discussions kind of miss this, is when we say the word server, we don't necessarily mean like a literal server. It's more about the fact that they run ahead of time. So for example, so Next.js is one of the frameworks that implement the server component specification. And in Next.js, the default is actually build time. So server components run at the build time by default. And in that case, your machine is kind of like the server, and it happens during the build. And so this lets us, if you can do like fs.read file in your server component and read something from a file, for example, like a markdown blog with a bunch of files. You can just read them in your React components. But then when you want to add a little bit of like like a theme toggle or some kind of like a comment form or something like this, like that can run on the client. And then for some other routes, like maybe like a settings page, that could actually use the server. So it is flexible in terms of when exactly it runs. And then this is like from the perspective of like old school web development, but you could also contrast and compare it with today's approaches, because you could also look at server components as kind of a React take on how to do like data fetching, and it has some I think it has some overlap with things like get server-side props in Next.js, or remix loaders, or Astro, that's and islands. So those are like different newer technologies that kind of address the same space. And then you could think of React server components as kind of, what does it look like to address the space in a way that feels native to React? So what is the React take on how to do these kinds of things, instead of kind of bolting them on top of existing React?
So in that context, like as you said, everything that you can do with React Server Components, you could have done before in other ways. They might not have been as good, or they might not have been as integrated with React, or, quote unquote, the React way. But that kind of leads me to the question that I wanted to ask, which is, React is, the king of the hill in terms of frameworks. According to the Chrome User Experience Report, there are as many websites built using React as all the other frameworks put together. And not only that, but the retention rate for React is also great, according to JS Survey. So you've got most of the users, and they're pretty happy with what they got. And as I said, they had ways of doing what you're doing with React Server Components in React before that. So given that you had all those happy users and they were able to do their work, why did you feel the need to, create such a huge disruption in the React space with React Server Components? Why not just, keep on doing what you were doing before? What's the motivation? What was driving you forward?
I don't fully agree with the characterization that you could do everything. I think that's not strictly saying true, but it is in details. So one example is that you couldn't really componentize server or build logic. And I'll give you like a concrete example. So let's say you have a Markdown renderer component. And let's say that your site is static, so it's essentially like a blog, like a blog. And you currently if you put this as a component on npm, so you put a component on npm, your Markdown renderer that imports some Markdown parsing library and turns that like into React tree or HTML. If it is on npm, then the only way you can consume it in React is to consume it at runtime. So the only kind of way you can, if you add it to your React-powered site, even if you build it with a server-enabled technology like Remix or old Next.js, then this Markdown library will be shipped to the client bundle. Unless you completely get rid of JavaScript, and then you have nothing is interactive. But if you even have a little bit of interactivity, the default way to consume components is they're always shipped to the browser. And so this is pretty, for some cases, this is pretty inefficient. Like with this Markdown example, if you're building a blog that, that is static, why can't you just do this at the build time? And we do not have any way to put a React component on NPM that does a bunch of stuff at the build time. It's just not possible. You can put a function that then you can tell, call it from your remix loader, but then that's not composable because, what if you have multiple places where you want to do that? What if you have code highlighting? You want to do parsing of the code during the build, because it doesn't make sense to ship a JavaScript parser to the client just for code snippets if your code snippets are static. And so you can't create a code highlighter component that does this kind of work during the build. And then the thing is, with server components, you have this flexibility, And the beautiful thing about it is that you don't actually need to do anything special for it. So if you have an existing code highlighter component that just takes some props, returns some output, in the server components model, if you import it from a page that runs, or like from a server component, then it will also run in the server-only environment, and so it will not be shipped, like the parser for JavaScript would not be shipped to the client as a dependency. Whereas if it's, if you import it from like a blog post preview page where you're typing into an input and it's a client component and it updates the state, and you want to render a live preview, in that case, it will be included as well. So the new, like that's an example of a new capability. But you can also think bigger, because, it's like it would also enable you to componentize server-only logic. So imagine you could have some kind of like a dashboard component. Maybe your internal company, you're building a bunch of components. You can have a dashboard component that you put on your like private NPM registry or whatever you use for sharing code. And the dashboard component can call your microservice, or can call your, it can, read from your database layer, but it is isolated. So it can specify, how to load data for itself, and you could still compose it in the React tree of components. So I think that is a new capability. That's like, what if you could put server only or like build only logic on NPM and compose it and componentize it the same way that, what React enabled for the client ecosystem, to enable this same kind of composition for the server and build ecosystem, and have these things work together, because it's really, it's not, one or the other world. It really lets you combine them seamlessly and have a component NPM that has both client and server parts, and you just import it and render it. So I think that is a new capability. But as for like the people being happy with React today, I think that's also an overstatement. Like, sure, it's it is usable, but if you listen to what people are complaining about,
it's
like
usable.
A lot of the complaints, yeah. But people are complaining about like data fetching in UseEffect, for example. That's a big one. And in general, like people say, "Oh, I wish it was easier to do data fetching." And if you try to do data fetching well, like you have to think about, how do I deal with loading indicators? How do I avoid loading waterfalls? How do I, how do I kind of compose these things together? And then it's actually funny, because one of the like very early feature requests was for React, as soon as promises was a thing, one of the early requests was like, why can't you just like async await and just like do data fetch in this way? Like, why can't you just like await a fetch and then return a bunch of UI?
And why can't
that's something that people, yeah. So that's what it took us a long time to figure out, because if you want to do that, you have to figure out, okay, what should happen while it's fetching? Like, how do you express, where to put the loading state? And that is, that is suspense. So we figured out, you put the loading state in your tree, that is how you solve it. Then you have questions of like, well, but what if your component is waiting for something, but then the parent component updates a state, and so you have to like synchronously do something like typing into an input. How do you deal with a part of your UI kind of being stuck because it's fetching something? And so the answer to this, well, you just spread apart your tree into parts that run on the client, and so they have to be able to synchronously respond to input, and then parts that run on the server or during the build that can be async, because they're only triggered when on the first load, and then during a refetch or a navigation. So when you just type something, it doesn't force them to refetch. So there's a lot of kind of complex questions, but I think one way to think about it is like, yes, you should be able to async await inside components. It just took us 7 years to figure out how, and that is our answer. Like server components is our answer to how. Joe?
Yeah, I think you really covered it. People have been asking for, how do I do data fetching and routing and and those things are very related, right? They've been asking for a long time, and this is like our answer. So, yep.
Well, one of the points then that you made, one of the first ones, was about the fact that with React Server Components, one of the biggest benefits is that I don't need to download code that only needs to run at build time or server side and not on the client. And you gave the example of the markdown parser for a blog or the blog post itself. If we look at most blog pages, the biggest part of the page is totally static, and therefore the whole concept of hydrating that part seems incredibly wasteful. And indeed, a lot of frameworks these days are looking at ways to avoid this client-side hydration, and React Server Component seems to be your answers to that question. But having listened to you talk in videos and other podcasts, it seems to me that in many ways you kind of look at that optimization as sort of a side benefit, a really intended benefit, but a side benefit nonetheless. So that if I understand correctly, your primary purpose is about the data flow from the server to the client, or replacing the concept of APIs, or is it something else? Like, what is the primary purpose of React Server Components, really?
I think it is the Markdown example is a nice illustration of optimization, right? Because it's something that could run on either side, but really it's not necessary to run it on the client if the blog is static. One thing to note there, though, is there are solutions that, for example, like Astro, where that really go into this direction of, if it's static, then it should just run only at the build, or only during only on the server, and then you have hydration only happens for so-called islands or like pieces of interactivity. But I think with one thing that is important here is in React, we want to be able to reuse code, if it can run in either environment. So like with the blog post example, maybe on the blog post page, we want it to behave kind of statically because it doesn't change. So it doesn't make sense to ship code there, but you could use the same exact component. Like you can literally import the same component in your in the part that has a live preview. And so there, the same exact code could work on the client so that it responds as you type, and you wouldn't download that code, unless you're actually on the compose post route. So unless you're actually the author of the blog post. So I think that's one important difference with these approaches that try to be let's make as much as possible static, is that in Astro, for example, you couldn't do that, because if in Astro you start with a static blog post and then you're oh, I also need to show a preview of this on a different route as the user is typing. Now you have to rewrite it from Astro piece to React piece, and either you have code duplication, or you have to de-opt and ship client code in the first example too. But as you said correctly, I think that's just an example of just it nicely comes out of the paradigm. I think a more important piece, one of them is that some components can only work on the server. And so this is different from optimization, right? It's imagine if you're familiar with Django, this Python framework for creating apps, there's this plugin called Django Admin that lets you generate these tables where it just connects to your database and kind of gives you a default admin template where you can see the different rows, you can edit individual entries, and so on. And that is something you couldn't really put into a component before at all, in React land, because it has associated, server code with it that is server only. And so I think that's one key feature, is that now you can write componentized pieces that are server only. I think that's and reuse them. I think that is important. But if we talk about like the big picture and like why we're doing this at all, I think it's just because we think the mental model of just writing the mental model of like request response is incredibly powerful, incredibly it's very nice to express data logic in it, where you just take some data, wait for it, and then return the response and kind of don't think about it. Like, it's not stateful. And that's very nice for data fetching. And then the clients, the parts that we use React for, where you're like typing something and something updates as you type, or you have some kind of complex forms or some kind of complex flow that like drag and drop, like something interactive. Like, that is something that state is really good at, and something that it's very useful for. And so it's just about, why don't we give you a way to do data in a way that feels stateless, and so it's easy to write, easy to wait for, and to keep using state for things that are actually like stateful, as in the user did something and we want to remember it, and then have those things combined together very seamlessly. So I think it's mostly about enabling this way of writing, where you use both sides for what they're best at, and then can compose them together seamlessly, and you can componentize them so that different people, different teams can write pieces of it and like put them on npm and just put them together. And that's kind of like what people like about React already, and we want to do that for the server and for the build time as well.
Yeah, I would just add, I think when you're faced with like kind of multiple different use cases, one way to approach that is to kind of have targeted solutions for different use cases. So you can say, oh, okay, we want to make it possible to not have to download the markdown renderer to the client in this use case. So let's try to find a targeted approach there. And then we want to do nested routing. Let's find an approach there. And then we want to do make it easier to do data fetching. And that's often a reasonable approach, is to think very kind of use case by use case, because you often don't need a more general solution. But I think in this case, it really was something where we began to see like that these are all related. Routing and data fetching are related. The reason that we're downloading this extra code is related to the data fetching, and so then that all kind of having this kind of unified solution is actually simpler than attempting to solve each of these on their own. And then once you build that, then a lot of things just naturally fall out of that different programming model. And so it kind of looks like, oh, like you're solving all these different things, you're getting all these different benefits. I think, as Dan said, the real key is the sort of data fetching piece and enabling to kind of have you access the server data, easily, and then the kind of single rendering kind of programming model. And then, yeah, a lot of nice stuff just falls out of that, because it is a very cohesive model for solving the problems that people are facing.
Just to clarify that in React Server Components, per my understanding, in these server components, you can just make a database query directly, because it's running on the server side next to the database and doesn't have any client-side restrictions.
That's
and
right.
Then it kind of passes, or the data trickles down the tree as it does in React, just as props into the child components that can be client-side components. So it's a way to pass data from the server to the client using the React props mechanism, correct?
Yep, that's right.
Okay.
Yeah, and I think that's if we talk about like a classical data, if you think of like a classical React data fetching example that people learn like in boot camps, it's usually a piece of state and some use effect that kind of fills in that state. And it already kind of feels weird to write, like, the shape of it looks kind of strange. But even if we set that aside, like, why are we thinking of that data as state? Because state is something that is that you need to, like, the UI needs to remember, right? Like, classical examples of state are, for example, like a toggle button, right? So it's stateful because it was in some initial state, so like it was untoggled, the user did something, and the button has to remember what the user did. So the button has its own memory, and that is what state really is. And then this example of like a comments widget that has a state of comments that's like initially empty, and then somehow just making that component appear causes it to like go to the server and fill in and then set some state. Like the user did not really do something to fill in the comments. It's not really like the comments widget trying to remember something. And I think that is like the conceptual idea here is, what if instead of thinking of a server as like a different thing, or the file system, for example, right? Like it doesn't have to be a server, it could be during build. But what if instead of thinking of this like as a piece of state that the component remembers, that somehow the component tries to keep synchronized using effects with something external, what if we just think of it as we just want to pass some props from the server? And so it's still this top-down data flow where things are, the component takes comments as a prop. It just happens that this prop is not filled in by the client, it's filled in from the server. And then if you want to, the other thing that's like really important about server components, and I think a lot of explanations miss it because of confusion with server rendering. So this is like I think this is something we need to be very clear about, that server components doesn't really have anything to do with server rendering. These are like completely different technologies. It just happens that server rendering or rendering to HTML is beneficial for the first load. So we recommend to use server components together with rendering to HTML for the initial page load. But the important difference is that in traditional server rendered solutions for React, so like the old Next.js, the Remix, Gatsby, like all of these solutions, server rendering or rendering your React tree to HTML, it only happens once, right? So it happens when the page loads. That's when we turn it into HTML. And then from that point on, the only thing that, re-executes on the server, like for example, during navigations, or if you update some data, in these frameworks, usually you can only kind of refresh small pieces of code. So in Next.js, it's like get server-side props. So you can tell that thing to re-execute and give you new props. In Remix, you can tell the loaders to re-execute and give you new data. And then server components extends this to the entire tree. So in server components, you can say, I want to refresh my tree. And so if the comments that you get from the database is different, the server is going to pass you new comments as a prop. So it's kind of server components puts if you know this concept of unidirectional data flow in React, where things flow down as props, and then when you want to change something, you update state at the top, and then things flow down again, and they flow always down. You can think of server components as adding the server to unidirectional data flow, where you can say, I'm changing the comments on the server, like in the database, and it just like refreshes that, your server component route, and the new comments just flow down, and you don't need to do anything extra to keep them in sync or like to refetch them. It's just like a unidirectional data flow refresh, the same as it happens on the client when they change the state.
Right. So that and that means like that we're not blowing away client side state. You're keeping. So if you had some interactive component within that, that's going to in kind of React terms reconcile. So it's just as if you'd re-rendered as if all that had happened on the client side, that existing interactive state is not lost as this server side refresh happens. Which is, I think, another piece where, like, you talked about other solutions can maybe approximate some of what server components can do. That's the kind of thing that often gets lost in these other approaches. Whereas server components are able to keep that keep kind of the existing client side state around.
Yeah, I had a question about all of this. Thank you, by the way, Joe and Dan, for answering. This is really educational. And the question I have, I think, is something that a lot of the listeners, developers, would be interested to hear the answer for. Because it sounds to me, so I'd previously thought wrongly probably that server components was the primary solution server components was aiming to make was around bundle size, because indeed shipping, like this Markdown example, instead of shipping the entire Markdown render, you ship, just the output of it, as it were. And I always thought bundle size was the main theme, but hearing this conversation, it seems like data fetching is also just a huge part of it. So it sounds like server components is designed to solve a whole bunch, as it were, of problems. But you said, Dan, talking about data fetching, and the community asking, why can't you just do async await as function components? I hear that data fetching can be an answer, but at the same time, the question, and this may be a very silly question, but the question in my mind is, the async primitives on Node.js on the server are very close, if not the same, to Node.js, or if not the same to the browser, such that we can do async await in the browser also for client-rendered applications. So the thing that I don't fully understand, I think a lot of developers listening would also probably like to know, is why can't we, or indeed maybe we can, have React function components called asynchronously at the render phase? Is that like, it sounds like from the previous conversation that it wasn't possible, but what I know tells me this is actually possible. It's just probably not ideal.
If I can add on top of that before you answer, one of the things I really liked when you guys introduced hooks as opposed to class-based components is that it suddenly made it very easy to transition from stateless components to stateful components and then back again. All you needed to do was add use state. That means components were components, whatever their functionality happened to be. And like Tejas is kind of saying, this is kind of not the case with, at least for now, with server components versus client components. And by the way, I hate the term client components, I have to tell you, because client components can run on the server. But it's not the same because the synchronicity model is different. In server components, like Tejas said, you can just put async on the component function and await the fetch or the database query or whatever. But in the client-side components, you can't do that. Like, why? And Tejas, I hope I kind of echoed your question.
Yeah, definitely. And I think so. Again, my assumption that may be wrong is, while async components on the client side are technically doable in the browser runtime, the server component approach as it is right now solves that, but also a whole bunch of other problems like data fetching et al. That we've discussed. But now I'm curious to hear what the team has to say.
Joe, do you want to go first?
Yeah, I mean, I think you already kind of touched on this in one of your earlier answers, Dan. Like, there's just because, so yeah, for sure. I mean, obviously, async await works in the browser, but that's only part of the only part of the problem. What do you show while a component is loading its data, right? You need a way to represent that. I think in the past, frameworks would basically, I think some version of Angular let you just have a promise, and if it was loading it, just that property was null in your template, right? Which, okay, that works, but we really want to give the user more control over what is being rendered at any given point in time. So
sorry to interrupt, but Suspense has a fallback prop that also
right, but and that's the point. That's what I was getting to. It's like, so you need Suspense, right? And so yeah, we kind of needed at least like the server components like infrastructure to even make a lot of that possible. But yeah, I think like Dan, you know like a little more of the details of like the internals for why it's a bit more challenging.
Yeah, I think I would maybe approach it slightly differently, and I think the question of like why can't you just do this on the client? The answer is primarily related to waterfalls. So if you imagine, and it's the same, I think it's also an answer to the question of, well, why can't you just put a server component in the middle of your client tree? So it's also like a question about incremental adoption, because I think the first thing that people kind of run into is if you try to, they want to think like, how do I adopt this incrementally? Like I have this React tree, it's like completely client, and then I want to like put the server component somewhere in the middle. And we have a rule that says you cannot import, and note I did not say render, I say import. These are two different things. But you cannot import a server component from a client file. And the reason for this limitation is, and it's the same as answer to like the question about can't we just do async await on the client? Well, let's imagine that we do that, and let's think through the consequences. So I think there are two different ways you could imagine. There are two different ways you can imagine this kind of playing out. So maybe like the first way is, let's say everything is on the client, right? So there is no concept of like server components. Your async await. We just add support for async await in component functions. And I think what you'll see is that it encourages incredibly inefficient user interfaces, inefficient loading. And I mean, it's fair to say that this is already status quo with useEffect and data fetching, but we kind of have a slightly higher bar than, because like when people do useEffect for data fetching, it's usually because they have just like 2 or 3 fetches or something like this. It's not that they write their whole component tree where like fetch on every level. Because if you try to do that, like if you try to scale it up to any non-trivial app, then you'll see it's incredibly slow, because you start rendering for example, the parent component like a profile page, and it does, let's say it's like async await, so it like awaits for some basic like profile data, and so that goes to the server. So you're introducing latency right away. Like that has to go to the server anyway, because that's where your data is, and then like it comes back, and then you continue rendering, and then you bump into like profile timeline, like, oh no, I have to go back to the server again. And imagine if there's like some latency between server and client, like it's like if there's like 3 seconds, it's like 3 seconds on every single level that you want to get something. And so it just doesn't scale to any non-trivial data requirements. So I think that is the answer to why we can just do this on the client only. But I can also answer the rest.
So just to say it a bit differently, what you're saying is that there's no recursive promise all, effectively. That because you've got a component embedded within a component, the external component is a single wait, the internal component is a single wait. You don't render the internal component until you finish with the external component, so you're waiting on the external component, and only after that's done, you're waiting on the internal component, where ideally you would have wanted to wait on those 2 pieces of data in parallel.
Well, I think what you really want, what you're really describing there, is to say you want to be able to run, like how do you avoid that waterfall, right? How do you avoid that? Well, the only option, when you think about it, like from the implementation perspective, is that the server has to know, after I finish fetching this one query in the parent component, I'm going to have to go and execute these next async functions in the client. How does it know what they are? Well, you have to actually render the parent component on the server to figure out what client components are going to be rendered with what props and what async functions are going to get called there. And that's server components, right? So yeah, like that it's just that if you want to avoid those waterfalls, you have to move all the appropriate logic to the server, or else there's no way around it. There kind of can't be a JavaScript solution, given that there's user code, right? That's actually running in between the data fetches.
Yeah, I want to clarify, because I think it's not about promised at all or something like this. It's not sufficient, because if you have a parent component and like it wants to fetch something, like even if there is I want to clarify, sometimes waterfalls are just inherent. Like you can't avoid waterfall in principle, in the sense that sometimes you need to go to, like, imagine you need to go to one service, that tells you some information that you can like start rendering stuff. and you use a piece of this information to go to another service to fetch something. Like that's a waterfall you cannot avoid, because there is the child you're going to render depends on the data that the parent receives from the fetch. Like it's kind of unavoidable. But the question is more about where does that waterfall happen? And so the problematic case is like, we go to the server, there's like a lot of latency in between potentially. We figure out, okay, like here's what we're going to render, and now like we return that to the client, like return the data to the client, and then the next, the component inside. Now we know what the component inside is, because now we know its props. Now we know what's being passed down to it. We've run the parent component's logic, and then that component is like, oh no, I need to go to the server. It's like, imagine if you were like you had a shopping list, and like the person who figures out, the person who kind of, the person who's cooking is like, I need I need you to like go to the shop and tell me what fruits are in the shop. And so you go to the shop, you figure out what the fruits are, you come back and you tell me, they have like bananas and oranges. And then they're like, well, I'm going to need some oranges. And since they have oranges, let's also get some spices. And so you can't go back to the shop. Like, that is silly. Like, ideally you want to know, like, here's like here's the entire like list. If they have oranges, then like get oranges and spices. If they don't have oranges, let's get like some apples and some cacao. I mean, I know this doesn't make sense.
No, you made me hungry.
But, yeah. But the point is just like, you don't want to keep coming, there is some inherent waterfall sometimes, but you want that waterfall to happen at the shop. Like you want to, you have your list of like what thing you're cooking. You go to the shop, and that's where you make the decisions about, they have oranges, great, I'm going to have some of those, or otherwise I'm going to have these things. And so even if there's like inherent waterfall, we just want there to be just one request between client and server, but then on the server is where we actually like run this logic. And so this avoids going back between server and client, and spending all this latency, because that can be really slow, and that it happens at every single level of nesting.
I was just going to say that makes a lot of sense. So like the answer to the question that I asked, it sounds like theoretically you can do these async components on the client side, but it's probably not the ideal solution, because server components solves the problem of bundle size and data fetching in its like peak efficiency way.
I would say not that it encourages a less ideal solution; it encourages a less ideal architecture. I think would be the way to phrase it, maybe.
Correct. You mean?
Yeah, but I also sorry.
I was just going to say, you mean the async client components?
Yes.
Encourages a less efficient. Yeah. Okay, that makes sense.
There's also another part of it which I think is really important, and that kind of answers the question of why can't you just nest? Why can't you just like put a server component in the middle of your tree as an adoption strategy, right? Like, why can't you just like render a server thing somewhere in the middle? And the answer to this is actually related to this problem of, imagine that you could. So imagine that you have like an async function in the middle of the tree, of your existing tree. Whether it runs on the server or on the client, it's actually the same problem. So imagine that you have this async function, and then some state updates above this component. So like normally in React, when the state update, like you have a state update, you want to re-render the tree, right? Like the tree needs to be consistent. So if you're updating the state, you want to do re-renders. Like sometimes maybe you bail out of re-renders for performance. But still, like if you're passing some piece of state down as a prop, it has to go through every level, and it has to reevaluate, what is the UI given this new value of this prop. And so imagine that you put like a server component, you could put an async function somewhere in the middle of the tree, and then let's say you add, an animation, or you add a form above it, or you add something that, a theme toggle, like you add any piece of state above. And so now what do you want to happen when that the prop you pass kind of flows down through that tree? But the naive way to do it is like you would if we allowed that, you would accidentally trigger this async refetch all the time, and it would get stuck all the time because it takes some time to kind of go to the server and back. And this is especially a problem if this component just does some prop plumbing. So maybe it just takes some prop from above and it passes down to something that actually needs it. And so now like maybe that prop has not changed, but it's still kind of like having to refetch this stuff. And so what server components forces you to do is to decouple these two data flows. So you have the server data flow that is only the data that's needed by the server. It flows down on the server, and so you don't actually know what the client state is on the server. Like you don't know what you only know the URL or some kind of like which page you're rendering, but you don't really know like what is the value of every checkbox and so on. And then you have the client logic that responds to state changes in real time. And so the beauty of this is that with the server components model, it's really like the server is kind of the first pass. So the server just figures out the data. And then like on the client, if a state updates, it never needs to, it never triggers server refetching by default. Like if you update like a theme toggle, it just updates, the client components, because on the client, from the client's perspective, the server has already ran. So like the client only sees kind of the server output. So it just skips over it. It's like it's pre-computed. So you don't have the situations where you just added a bit of state and suddenly you're refetching like 10 times more often. And that is like a big, that's like a big thing we're avoiding.
That makes total sense, especially when you consider that server components can run as part of the build, like you said before. So obviously they could have executed long before the client-side session ever executed. But I have to say that the fact that you have like these two kind of parallel data flows is one of the big gotchas. Like it took me a while for this realization to actually sink in to the extent that when you ask those riddles on Twitter with like the polls, that's the one I got wrong. So yeah, it really takes like a while to adjust your mental model to that, for sure.